So, good day, students. So, our first topic for statistics and probability, that will be random variable. What do we mean by random variable? It is a numerical measure of the outcome from a probability experiment, so its value is determined by chance. For example, a die is rolled 2 times and a random variable x is assigned as the number of times a 6 appears. So we are finding a random variable here. So we have types of random variable. First, this is discrete random variable and continuous random variable. So first, we have the discrete random variable that defined. It is a random variable that has values, either a finite number of possible values or a countable number of possible values. The examples of discrete random variable are: first, number of students present. Then number 2, number of heads when flipping 3 coins. Next, we have the continuous random variable. What do we mean by that? It is a random variable that has an infinite number of possible values that is not countable. So the example of continuous random variable are height of students in class and time it takes to get to school. So here are the summary for types of random variable. Next, let's have the distinguishing between discrete and continuous random variable. With that, we use capital letter like X, Y, and Z to denote the random variable and use a small letter like X, Y, and Z to list the possible values of the random variable. For example, a single die is cast, the number of pips showing on the die. So here is the answer. A single die is cast. X represent the number of pips showing on the die. And the possible values of X are X is equal to 1, 2, 3, 4, 5, and 6. So let's have another examples in distinguishing between discrete and continuous random variable. So, determine whether the following random variables are discrete or continuous, then state possible values for the random variables. So we have a given random variable, possible values, discrete or continuous. So let's have first the given. Number 1, inspect 20 deliveries of cellular phones. Number 2, get some rice from a 20-kilogram sack. Number 3, number of light bulbs that burn out in a room of 10 light bulbs in the next year. And number 4, the length of time between calls to 911. So let's have number 1. What will be the random variable? The random variable for number 1, that will be number of defective cellular phones. The possible values we have for number 1 is X is equal to 0, 1, 2, 3 to 20. Is that discrete or continuous? That is a discrete. So let's have number 2 example. Get some rice from a 20-kilogram sack. So the random variable for number 2, that will be weight of rice in kilogram. What are the possible values for number 2? That will be X is less than or equal to 20 but greater than or equal to 0. Now, next column, is that a discrete or continuous? That will be continuous. Next, let's have number 3, the number of light bulbs that burn out in a room of 10 light bulbs in the next year. So the random variable here is the number of light bulbs that burn out. Then, the possible values is X is equal to 0, 1, 2, 3 to 10. And next column, is that discrete or continuous? That is a discrete. Then let's have the last example, the length of time between calls to 911. The random variable for number 4, that will be the length of time, and the possible values is time greater than 0. And next column, the last column, is that a discrete or continuous? That is a continuous. So let's proceed to the probability distribution. Probability distribution provides the possible values of the random variable and their corresponding probabilities. Next, a probability distribution can be in the form of a table, graph, or mathematical formula. Then last, it defines by a probability mass function denoted by the probability of random variable x is equal to x. So, we have requirement of discrete probability. Let P of x is equal to x denote that the probability of the random variable x equals x. Then, first, summation probability of the random variable x equal to x is equal to 1. Assures that the sum of the probabilities for all the possible values of a random variable is equal to 1. Second, probability of the random variable x equals to x is less than or equal to 1 but greater than or equal to 0. Requires that probabilities should be non-negative. So identifying probability distribution is the following given as a probability distribution. So we have table 1 and table 2. So for table 1, all you have to do is add all the probabilities and get the sum. So we have 0.97. Therefore, table 1 doesn't meet the requirements of a probability distribution because the summation of the probabilities is not equal to 1. For table 2, add all the probabilities and get the sum. So we have summation probability of random variable x equal to x is equal to 1. So, table number 2 assures that the sum of the probabilities for all the possible values of a random variable is equal to 1.
For discrete probability distribution, each possible value has a non-zero likelihood. Furthermore, the probabilities for all possible values must sum to 1. Because a total probability is 1, one of the values must occur for each opportunity. So, this is the requirement for you to consider that the given is a probability distribution. The probability or the total probability must sum to 1. So, let's have this example. 3 coins are tossed and the random variable x gives the number of tails. So in here, we have the sample space. When we say sample space, this is the least of all possible outcome. So in here, we have 8 possible outcomes in terms of tossing 3 coins. And then we have the range space. When we say range space, it is the interval that contains all the values of the random variable. So since we are looking for the number of tails, there are among the possible outcomes, there are intervals 0, 1, 2, and 3 number of tails in the list of possible outcome. We use tree diagram to list all the possible outcomes. So for the first coin, we have head tail. For the second coin, it is head tail, head tail. Then for the third coin, it is head tail, head tail, head tail, and then head tail. So that is why we can come up with the 8 outcomes, which are head head head, head head tail, head tail head, head tail tail, tail head head, tail head tail, tail tail head, and tail tail tail. So that is why we come up with the sample space having in 8 possible outcomes. In terms of range space, since the given is asking for the random variable x, which gives the number of tails, so therefore, all you have to do is to count the occurrence of tails in all outcomes. So there will be 0, 1, 1, 2, 1, 2, 2, and 3. Since in terms of range space, we are referring for the interval, so once there is the number that is being repeated, all you have to do is to write it once, and you should write it in ascending order. So therefore, our range space will become 0, 1, 2, and 3. probability distribution can be in the form of a table. So in terms of the probability distribution table, the first column is intended for the value of the random variable x, which are the range space, the intervals 0, 1, 2, and 3. And then the next column is intended for the probability of random variable x equals x, or the px equals x. So in order for you to supply the necessary value on that column, you will be using this formula. The p of x is equal to x is equal to number of ways it can happen over the total number of outcome. Say for example, on the first one, we have 0, which means we are asking for the probability of getting no tail, the number of tails. So that is, based from the sample space, we have 1 possible outcome, or one outcome having no tail. So that would be 1 over the total number of outcomes, that is 8. So that would be 1 over 8, or you can express this in decimal. So this will be 0.1250. Next row is 1. So the probability of getting one tail. So based from our sample space, we have 3 outcome that has one tail. So that would be 3 over 8, or 0.3750. Next, we have 2. So the probability of getting 2 tails. So based from our sample space, we have 3 outcome as well. So that would be 3 over 8, or 0.3750. Last, we have 3. So based from our sample space, the probability of getting 3 tails, so that would be 1. So 1 over 8, or 0.1250. So again, in order for you to consider that the given is a probability distribution, you have to get the summation of the probability of random variable x equals x, or the second column. So in order for you to do that, you just have to add all the values and get the sum. So since the summation of the probability of random variable x equals x is equal to 1, therefore we can say that this is a probability distribution. Also, we can represent probability in the form of graph, which is the probability histogram. So, a probability histogram is a histogram in which the horizontal axis corresponds to the value of the random variable, and the vertical axis represents the probability of that value of the random variable. So on the horizontal axis, it is for the value of the random variable, which are the 0, 1, 2, and 3. And then for the vertical axis, it is for the probability of random variable x equals x, which are 0.1250, 0.35750. So based from the histogram, the probability of getting no tail is equal to 0.1250. Next, the value of 1, which means the probability of getting one tail, is equal to 0.3750. Next, for the value of 2, which means the probability of getting two tail, is equal to 0.3750. Next, the last, the value of 3. So the probability of getting 3 tails is equal to 0.1250. Next, let's have the mean of a discrete random variable. So the mean of a discrete random variable is given by this formula. So in order for you to solve for the mean of the discrete random variable, you will be using this formula. So this is how you represent mean in terms of symbol. The mean is equal to the summation of the product of the random variable x and the probability of random variable x equals x. So we'll just continue the previous example. Again, with 3 coins are tossed and random variable x gives the number of tails. So we have here the sample space and the range space. So we'll just continue the previous example. So we already have the first two column. So next to that, the third column is intended for the product of the random variable x and the probability of random variable x equals x. So you just have to multiply the random variable and then the probability of random variable. So 0 multiplied by 0.1250, any number multiplied by 0 is always equal to 0. Next, 1 multiplied by 0.3750 is equal to 0.3750. Next, 2 multiplied by 0.3750, that is equal to 0.75. Plus 3 multiplied by 0.1250, that is equal to 0.3750. Again, going back, in order for you to solve for the mean of the discrete random variable, you just have to get the summation of the product of the random variable x and then the probability of the random variable x equals x. So you just have to add all the values in the third column. So that would be equal to 1.5. Therefore, the mean is equal to 1.5. So we are now at the variance of discrete random variable. So the variance symbol. So in order for us to solve for the variance, we'll be using this formula. Wherein variance is equal to the summation of the squared of the difference between random variable x and the mean multiplied by the probability of random variable x equals to x. So again, we will still be using the previous example. So for the first step in solving the variance, we need to supply first the values for the fourth column, which is intended for the difference between the random variable x and the computed mean. So 0 minus 1.5, that is equal to negative 1.5. Next, 1 minus 1.5, that is equal to negative 0.5. Next, 2 minus 1.5, that is equal to 0.5. And the last, 3 minus 1.5, that is equal to 1.5. So we are not yet done. So we're just finished completing the values for the fourth column. We now have the fifth column, which is intended for the squared of the difference between the random variable x and the computed mean. So in here, since we are looking for the squared, so that means we need to multiply by itself twice. So that would be negative 1.5 times negative 1.5, or negative 1.5 quantity squared is equal to 2.25. Next, negative 0.5 quantity squared is equal to 0.25. Next, 0.5 quantity squared is equal to 0.25. For the last, 1.5 quantity squared is equal to 2.25. And the last column is intended for the product of the squared difference of the mean and the random variable to the probability of random variable x equals to x. Okay, let's have first 2.25 times 0.125. The product is 0.2813. Next, 0.25 multiplied by 0.375, that is equal to 0.0938. Next, 0.25 times 0.375, that is equal to 0.0938. For the last, 2.25 times 0.125, that is equal to 0.2813. So in order for us to solve for the variance, we will just be adding all the values on the last column, which is intended for the product of the squared differences between the random variable x and the computed mean, and the probability of variable x equals x. So therefore, our variance will be equal to 0.7502. So therefore, our mean is equal to 1.5, and then the variance is equal to 0.7502. So in terms of interpreting the mean and the variance of a discrete random variable, so let's have first the mean. So based from here, the mean can be regarded as a measure of central location of a random variable. So it is the weighted average of the values that x can take with weights provided by the probability distribution. So based from the probability distribution, so having this histogram, so we can say based from our computed mean, which is equal to 1.5, therefore this is where you will be locating the mean. So it is the central location, which is based from this one, our computed mean is 1.5. Therefore, you will be seeing your mean here, 1.5. Unlike the mean, there is no simple direct interpretation of the variance. The variance measures how far a set of data is spread out, wherein a variance of 0 indicates that all of the data values are identical. That means all non-zero variants are positive. So in here, having a small variance, it indicates that when we have small variance, the data points or the data tend to be very close to the mean and to each other. Wherein, if we have high variance, it indicates that the data points or the data are very spread out from the mean and from one another.